Things I don't understand.
I'm excited.
The observer effect in quantum physics. So you're telling me that a subatomic particle, if we look at it, suddenly it assumes a definite state? How does the particle know it's being observed?
A particle doesn't know anything because it doesn't have awareness or consciousness. The reason this question comes up is because particles do behave differently depending on whether information about them is available. For example, in the double slit experiment, if the setup allows scientists to determine which slit an electron passed through, then the interference pattern disappears. So it can seem as though the electron knows that it's being watched. But physicists don't actually think that that's what's happening. The electron is responding to the physical conditions of the experiment rather than being observed in the everyday sense. The detector interacts with the electron and the interaction changes the quantum state. A useful analogy here is a footprint in wet cement. The cement doesn't know that someone stepped in it, but it changes because something has physically interacted with it. Similarly, a quantum particle doesn't know that it's being measured, but it changes because measurement involves a physical interaction.
Grief. Why did mammals develop the ability to feel sad? I don't understand. Like, you have other animals out there that are just like eating their own babies. Over here, somebody dies and we can be useless for like months, sometimes years. What is the evolutionary advantage of that?
Grief is most likely an evolutionary consequence of strong social attachment. Species that depend on long-term relationships for survival and reproduction, particularly many mammals and some birds, are most likely to show behaviors that resemble grief. Evolution favors forming strong bonds with mates, parents, offspring, or group members, which means that losing one of these individuals creates a powerful emotional response. Basically, you can't have deep attachment without also risking grief when that attachment is broken. And mammals are especially likely to grieve because they invest so heavily in their young. Many mammal offspring depend on their mother for many weeks, months, or even years. Imagine a world without grief. A mother mammal that wasn't distressed when separated from her infant might not search for it, might not protect it or feed it consistently, so her offspring would be much less likely to survive. So, natural selection favored individuals with very strong attachment systems, and those same systems also create intense distress when that bond is permanently broken. By contrast, many reptiles, amphibians, fish, and insects don't appear to show prolonged grief-like behavior, and this is probably because they generally form weaker or shorter-lived social bonds. For example, a female turtle will lay her eggs and leave. There is no long-term parent-offspring relationship for evolution to reinforce. But that said, we should be cautious about saying that other animals don't experience grief, because feelings are private experiences and we can't directly measure them in another species. Scientists can study behavior and physiology, but some animals may experience forms of loss that we haven't yet recognized, or that they may express in ways that are very different from humans. But humans are unusual because our relationships are unusually complex and long-lasting. We not only stay attached to parents, siblings, partners, children, and friends for decades, but we also have autobiographical memory, which means that we can imagine the future. So when someone dies, we don't just lose their presence right now, we also lose all the future experiences that we expected to share with them. And these uniquely human cognitive abilities can then prolong grief far beyond what we see in most other animals. Good grief, that was a long explanation.
Antibiotics. Like, how do the antibodies know to find the infection in the tooth?
Antibiotics don't actually know where an infection is. They simply travel throughout the body and they work wherever they encounter susceptible bacteria. After you swallow an antibiotic, it's absorbed into your bloodstream through your intestines. The blood then carries the drug all around your body. As blood passes through infected tissue, the antibiotic leaves the bloodstream and it enters the surrounding tissue. If there's bacteria present there, then the antibiotic can act on it.
Languages sounding different. French, for example, sounds very different from like Japanese. Animals in different parts of the world, like a cat says meow regardless of, where the cats are.
Languages sound very different because they evolved independently in different groups of people over thousands of years. Once human populations became separated geographically, their ways of speaking gradually changed, and this led to small changes in pronunciation, grammar, and vocabulary, which accumulated over many generations until the languages became very different. Also, every language uses a different set of speech sounds. Human beings can produce hundreds of distinct speech sounds, but no language uses all of them. For example, Japanese has relatively few consonant sounds and simple syllables, which gives it a flowing rhythm. German uses more consonant clusters, and English falls somewhere in between and has one of the largest collections of vowel sounds. A cat's meow is a vocalization that's produced by anatomy, i.e. the vocal tract, and it's controlled by instinct. A cat in Japan and a cat in Brazil have essentially the same vocal anatomy, which means that they produce very similar sounds. However, and this is interesting, people in different regions do think that the cats sound differently to them. Cats are making roughly the same sound, but each language represents it using its own spelling conventions and the speech sounds that are available in that language, which is kind of amusing when you think about it.
Medical appointment times, I don't understand why they say, oh, it's your appointment's at 3 o'clock, but be here 15 minutes early. I gotta be there 15 minutes early, just say 2:45.
I suppose it's easier to say 15 minutes for any appointment time because it's a uniform thing, rather than having to calculate what time that would make it exactly, which I assume is easy for the patient to do. Great questions, keep asking questions, and never stop learning.